The next question, you mentioned 9 and 10. Question 9 and 10 are both over the same thing. They just have different numbers. Let's see. Consider the weight. Yeah, it looks like they are the same thing. They just have the wording is a little bit different. So when we're looking at this Banzhaf power index, there are a few steps that we want to do for this. Step one is to list all winning coalitions. And so I usually just list all of the possible coalitions that we have. So like player one and player two. You can there's lots of them in this case. Stop, please. Player one and player two together. I didn't calculate this ahead of time, so let's see. 19 plus 17. That is going to give us 36. And so that's a winning coalition. We need, let's see, player one with player three. Let's look at that one. 19 and 14. That's 33, so that's also winning. Let's player one and player four. That's winning. And we don't really need these arrows here because I'll just delete the ones that are not winning. Now I've done player one with one of every one. So now we're going to do player two with every one. So player two is 17 and player three is 14. That's only 31. So that's not enough. So I'm going to try player two. Well, I know player two with player four is not going to work because player four has less than player three. So in order to have player two, I need to have player two and someone else. And so if I have player two with, say, player three and player four, then we have a winning coalition. And if we have player two with player three and player one, that's also a winning coalition. We know that 1 and 2 is a winning coalition, but if 3, actually we already have that, if 4 also votes that same way, it's still winning, even though the number's even higher. And because this is not the, sequential sequences, the order doesn't matter as long as I have those players listed in there. I believe that might be all of the ways to win. We have 1, 2, and 3, 1, 2, and 4. 1, 3, and 4 would be winning. And then player 1, player 2, like if all of them vote the same way. So to create your winning, your list of winning coalitions, it's just starting with trying to pair up 2 people who will have enough power together until you can't anymore, and then pairing up 3 people that would have a winning power, enough power, and then all 4 of them together. And so we have 1, 2, 3, 4, 5, 6, 7, 8 coalitions here that would be winning. I wonder... No, the 3 and 4s wouldn't work. So that's all the winning ones. And so now the step 2 is to underline critical players. And just a reminder that a critical player is needed to keep the coalition winning. And you can have 2 critical players in a coalition. For example, for the first one here, in order to keep that winning, we need both people to keep their votes the same. If either of them change their votes, it's no longer winning. Same thing with the second one. If either of them change their votes, it's no longer winning. And if either of these 2 change their votes, it's no longer winning. Since 17 and 14 isn't winning, and 17 and 13 isn't winning. We need all of these to also not change their vote, because if either one of those change their vote, you're no longer winning. For this next one here, since player 1 and player 3 is winning, we know that from this one, and player 1 and player 2 is winning, we know that from this one. Player 2 could change their mind. Player 3 could change their mind. It does not change the winning coalition. However, player 2 and player 3 do not have enough power, so they need player 1 to not change their mind. And that's the same thing for the rest of these 3 here, is we determined that player 1, in order to have only 2 votes, player 1 has to be part of that coalition. And so player 1 is a critical player. And then for this last one here, player 1 is also a critical player again, because once again, any one of the other 3 people can change their mind, and there'll still be enough voting power to win the coalition, as long as player 1 does not change their mind. So step 3 is to count the number of times each player is critical, and we're going to divide that in step 4 by the total number of critical players. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually, this one here is not a critical player, because if player 1 changes their mind, these 3 still have a winning coalition because it's winning over here. So that one actually doesn't, this one doesn't have a critical player. So let's count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our total is 12. And we're going to count just player 1. So 1, 2, 3, 4, 5, 6. Player 1 is critical 6 out of 12 times, giving us the index of 5/10. And then we'll do that same thing for player 2, player 3, and player 4. So player 2 is critical 1, 2, that's it, 2 times. And that's going to give us this repeating decimal. You can round it. I believe the computer will allow you to round it. Let's see, I'll test it out. Can I round to that? It doesn't like it when I round to this, so let me try and round to this one. It doesn't like it when I round there either. So I would not round it. It won't let me test it again to see if, and it gave me a new problem to see if I can round it, or what exactly it wants me to put in there. But anyways, let's move on. I would just test it out a couple times. This is the correct answer, but test it out a couple times to see which way it wants you to input the answer. 2 divided by 12. Yeah, that's the correct answer. Now we're going to look at player 3, which is 1, 2 times. So they have the same index as player 1. And then player 4 is 1, 2. And once again, they have the same index as the other 2.